Hello friends, I am Priyanka Runmane. Welcome back to your channel Excellent Coaching Classes Goa. In the previous video, we have learnt about Euclid's division lemma, Euclid's division algorithm and how to find HCF of real numbers part 1. The link of the previous video is given in the description box. Please go and check it out. Now, today's topic is real numbers part 2, in which we'll learn about fundamental theorem of arithmetic. That is how to find HCF and LCM using prime factorization method. So before we get started, please hit the bell icon and subscribe our channel for more such educating videos. So let's get started. Fundamental theorem of arithmetic. Now what does it say? Every composite number can be expressed as a product of prime numbers, and this factorization is unique apart from the order in which prime factorization occurs. That means any composite number which is other than prime number, it can be expressed as the product of prime numbers. Say suppose let's take an example of 4, which is a composite number. So it is a product of prime number 2, 2 into 2. And this factorization is unique, means every number has different factorization apart from the order in which prime factorization occurs. That means the order of the prime factors may vary. Let's learn it with the help of an example. Example 5. Consider the numbers 4 raised to the power n, where n is a natural number. Check whether there is any value of n for which 4 raised to the power n ends with the digit 0. The solution for this would be, let us take the example of a number which ends with the digit 0. So we already know any number which ends with 0 has 2 or 5 as its prime factor. So we have taken two numbers, 10 equal to 2 into 5 or 100 equal to 2 into 2 into 5 into 5. Here we can see that the numbers ending with 0 has both 2 and 5 as their prime factors, whereas 4 raised to the power n, if we break the prime factors of 4, we'll get only 2 into 2 raised to the power n. However, it does not have 5 as a prime factor. So, if any number, if it doesn't have 2 or 5 as a prime factor, it won't end with 0. So, it doesn't ends with 0. Therefore, 4 raised to the power n cannot end with 0 for any natural number n. Now, let's learn example 6. It says, find the LCM and HCF of 6 and 20 by the prime factorization method. So earlier, like we used to find prime factors of the numbers, we'll do the same way. So the prime factors of 6 would be 2 and 3. Similarly, prime factors of 20 would be 2 into 2 into 5. So 6 is equal to 2 raised to the power 1 into 3 raised to the power 1. Whereas 20 is equal to 2 raised to the power 2 into 5 raised to the power 1. However, LCM is the lowest common multiple. So, out of these two numbers, now we'll see the highest power of the prime factor. So, it is 2 raised to the power 1 here and 2 raised to the power 2 here. So, we'll take the highest power. So, it would be 2 raised to the power 2 into, here there is only 3 raised to the power 1. So, we'll take only 3 raised to the power 1 into 5 raised to the power 1, which is after multiplication comes out to be 60. Highest common factor. So, over here 2 raised to the power 1 is the highest common factor in both 6 and 20. So, that becomes our HCF. There is one more formula to find the LCM and HCF of the given two numbers, which is product of two numbers which could be A and B. So, A into B is equal to product of LCM into HCF, which is LCM into HCF. So, we will learn this by another example. Let's move on to example 7, which says that find the HCF of 96 and 404 by prime factorization method, hence find their LCM. So we'll find the prime factors of 96 and 404 as I have found over here. So prime factors of 96 are is equal to 2 raised to the power 5 into 3 raised to the power 1, and 404 is 2 raised to the power 2 into 101. So HCF by prime factorization method is 2 raised to the power 2. In the question it was asked to find LCM. So now we have HCF, we have two numbers, we can use the formula product of two numbers is equal to LCM into HCF. So 96 into 404, which are given two numbers, is equal to LCM into HCF. So what is the HCF? 4. We have substituted the values over here. 4 would go in denominator as it would get divided. After division, LCM comes out to be 9696. Therefore, LCM of 96 and 404 is equal to 9696. So example 8 is find HCF and LCM of 6, 72 and 120 using prime factorization method. So in this question we'll use only prime factorization method. So the prime factors of 6 are 2 into 3, 72 is 2 into 2 into 2 into 3 into 3, and 120 is 2 into 2 into 2 into 3 into 5. So prime factors of 6 are written over here, likewise 72 and 120 are mentioned in this way. So HCF of 6, 72 and 120, as HCF is highest common factor, so we can clearly see highest common factor is 2 raised to the power 1 in all three, and similarly highest common factor is 3 raised to the power 1. So HCF is 2 raised to the power 1 into 3 raised to the power 1, which is equal to 6, and LCM is equal to 2 raised to the power 3 into 3 raised to the power 3 into 5 raised to the power 1 is equal to 360. As LCM is least common multiple, so it would take the highest power of the given number or prime factor. So 2 raised to the power 3 is highest, then 3 raised to the power 3 is highest, and 5 raised to the power 1, which comes out to be 360. Now let's see the exercise 1.2. Question 1 says express each number as a product of its prime factors. So in the given question we have to find the prime factors and we have to express the given number into product of prime factors. So prime factors of 140 are 2 into 2 into 5 into 7, which is equal to 2 raised to the power 2 into 5 raised to the power 1 into 7 raised to the power 1. Second is 156, which is 2 into 2 into 3 into 13, which is equal to 2 raised to the power 2 into 3 raised to the power 1 into 13 raised to the power 1. Next is 3825, which is 3825. The factors of 3825 are 3 into 3 into 5 into 5 into 17, which is equal to 3 raised to the power 2 into 5 raised to the power 2 into 17 raised to the power 1. Next is 5005, which is 5 into 7 into 11 into 13. So 5 raised to the power 1 into 7 raised to the power 1 into 11 raised to the power 1 into 13 raised to the power 1. And the last is 7429. Prime factors of this number are 17 into 19 into 23, which is equal to 17 raised to the power 1 into 19 raised to the power 1 into 23 raised to the power 1. So after this we'll do question number 2, which says that find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to product of the two numbers. So over here we have to find LCM and HCF by prime factorization method, and then to verify we have to use the formula of LCM into HCF, which is equal to product of two numbers. So first part, 26 and 91, we are given with two numbers. We'll find the prime factors of 26 and 91. So prime factors of 26 are 2 raised to the power 1 into 13 raised to the power 1, and 91 are 7 raised to the power 1 into 13 raised to the power 1. So HCF of these two numbers are 13 raised to the power 1, which is the highest common factor, and LCM would be 2 raised to the power 1 into 7 raised to the power 1 into 13 raised to the power 1, which is equal to 182. Now we have to do the verification. So according to verification, we'll solve LHS separately and RHS separately. If the answer comes out to be equal, hence it is verified. So LCM into HCF, which is our left hand side, is supposed to be equal to product of two numbers, which is right hand side. So 13 into 182 also gives us 2386, and product of two numbers would also give us 2386. Hence we have verified both the sides, which is LHS equal to RHS. Now second part, 510 and 92. We'll find the factors of 510, which is 2 into 3 into 5 into 17, and 92 is 2 raised to the power 2 into 23 raised to the power 1. So HCF of both the numbers are 2 raised to the power 1, which is equal to 2. LCM of both the numbers is 2 raised to the power 2 into 3 raised to the power 1 into 5 raised to the power 1 into 17 raised to the power 1 into 23 raised to the power 1, which is equal to 23,400. So verification of two numbers are LHS equal to LCM into HCF, which is 23,460 into 2, which is equal to 46,920, and RHS is product of two numbers, which is 510 into 92, which is also equal to 46,920. As we can clearly see, our LHS and RHS is equal, hence this part is also verified. Now move on to the next part. Next part is 336 and 54. So the factors of 336 are 2 raised to the power 4 into 3 raised to the power 1 into 7 raised to the power 1, and 54 are 2 raised to the power 1 into 3 raised to the power 3. We'll find the factors by normal prime factorization method. As you can see, we have to find the HCF of two numbers, which is highest common factors. So common is 2 and 3. So 2 raised to the power 1 is common and 3 raised to the power 1 is common. So HCF is 2 raised to the power 1 into 3 raised to the power 1, which is equal to 6. LCM is 2 raised to the power 4 into 3 raised to the power 3 into 7 raised to the power 1, which is equal to 3024. Now the verification is LHS is equal to LCM into HCF, which is 3024 into 6, which is equal to 18,144, and the product of two numbers is also comes out to be 18,144. Therefore LHS equal to RHS, hence verified. So these questions should be done in this way. Now let's move on to the next question, question number 3, which says find the LCM and HCF of the following integers by applying the prime factorization method. So we normally have to apply prime factorization method in the given numbers, and we have to find the LCM and HCF using that. So 12, 15 and 21, we found the factors. As you can see, 12 is 2 raised to the power 2 into 3 raised to the power 1. 15 is 3 raised to the power 1 into 5 raised to the power 1. 21 is 3 raised to the power 1 into 7 raised to the power 1. So HCF is 3 raised to the power 1, which is the highest common factor in all these three, and LCM is 2 raised to the power 2 into 3 raised to the power 1 into 5 raised to the power 1 into 7 raised to the power 1, which is equal to 420. Now let's move to another part of it, that is part 2, which is 17, 23 and 29. So as you can see, the factors of 17 are 17 as it is a prime number, 23 is 23 as it is also a prime number, and 29 is also 29. We can clearly see all three are prime numbers. So their LCM would be the product of these numbers only, which is 17 raised to the power 1 into 23 raised to the power 1 into 29 raised to the power 1, which is equal to 11,339. And HCF would be equal to 1 as it is the highest common factor. Nothing else is common in all the three numbers. Let's move to the third part of the question, which is 8, 9 and 25. So factors of 8 are 2 raised to the power 3, 9 is 3 raised to the power 2 and 25 is 5 raised to the power 2. So over here LCM is 2 raised to the power 3 into 3 raised to the power 2 into 5 raised to the power 2 equal to 1800, and HCF is equal to 1. As we can clearly see, there is nothing common in all except 1. Now the next question is question number 4, which says that given that HCF of 306 and 657 is equal to 9, find LCM of 306 and 657. So we can find the solution by using the formula, which is product of two numbers is equal to LCM into HCF. As three things are given to us in this formula, which is two numbers and HCF. So we can substitute the values and we can find the LCM. We can bring 9 down and divide it. After cancellation, LCM comes out to be 22,338. Therefore, LCM of 306 and 657 is equal to 22,338. Next question, question number 5, which states that check whether 6 raised to the power n can end with the digit 0 for any natural number n. So we already know any number which ends with 0 must have 2 and 5 as its prime factor. So let's see how to do this question. The solution is, let us take the example of a number which ends with the digit 0. So 10 is equal to 2 into 5, or 100 is equal to 2 into 2 into 5 into 5. Here we can see that the numbers ending with 0 has both 2 and 5 as their prime factors, whereas 6 raised to the power n, which is equal to 2 into 3 raised to the power n, as factors of 6 are 2 into 3 and it is raised to the power n, so whole raised to the power n. We can clearly see that 6 raised to the power n doesn't have 5 as prime factor. Therefore, 6 raised to the power n cannot end with 0 for any natural number n. Now, next question is, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So let's take the first number, which is 7 into 11 into 13 plus 13. In this we can see 13 is common. So as 13 is common, we'll take common, so we are left with 7 into 11 into 1 plus 1. Now we'll multiply it. It would come out to be 77 plus 1, which is equal to 13 into 78. As we can clearly see, the above number have more than one factor, therefore it is composite. Now the second number is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Here we can clearly see 5 is common, so we'll take it out common. We are left in the bracket with 7 into 6 into 4 into 3 into 2 into 1 plus 1, which is equal to 5 into 1008 plus 1. We multiplied all the numbers and added 1 over here, which comes out to be 5 into 1009. Here also the above number have more than one factor. Therefore, it is also a composite number. Let's move on to the last question of this exercise, which says that there is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? So we have to find the minutes in which they'll meet again at the starting point. In order to find the answer, we have to find LCM of 18 and 12 to find the minutes in which they would meet at the starting point. So, we'll find the LCM by prime factorization method. So, prime factors of 18 are 2 raised to the power 1 into 3 raised to the power 2, and 12 are 2 raised to the power 2 into 3 raised to the power 1. So, LCM of 18 and 12 is equal to 2 raised to the power 2 into 3 raised to the power 2, which is the least common multiple for both, which is equal to 36. So, Sonia and Ravi would meet each other at the starting point in 36 minutes. So guys, so in the next video, we will learn more about real numbers, part 3, which is irrational numbers. Thank you for watching this video. For more such videos, please hit the like button if you like the video. Please hit the share button and share it with your friends and family, and hit the bell icon to subscribe our channel if you have not subscribed it yet. It will help you to know more about our educating videos from time to time. Also, do comment the topic which you wish to see in the upcoming videos. So, see you next time. Until then, bye-bye. Stay tuned.